Welcome to solverfy.
So here in this problem we are given with these two spheres of mass 2 kg. So mass of sphere 1 is equals to mass of sphere 2 and that is equals to 2 kg. And they are attached with these two wires, and at this point a force that has a magnitude of 15 Newton is being applied. Now there are basically two cases. We have to assume that in the first case alpha is equals to beta. This angle are equal, and then we have to calculate the vertical acceleration for the sphere 1 and 2 and for the system. Now next, in the case B, we have to consider that alpha is not equals to beta, and then we have to calculate the vertical acceleration of the system and the two spheres separately. Now to solve this problem, I will be considering the first case where alpha is equals to beta. So this is case 1, alpha is equals to beta. And in this case we'll be first calculating the vertical acceleration for the system. For that we can use Newton's second law of motion for the system of bodies, and which is sigma F net is equals to mass times the acceleration. This is a law. Now the net force, if we consider this as our whole system, so net force acting on the system is, we are considering the force in the vertically upward direction to be positive and the vertically downward direction to be negative. So here m1g would be acting in the downward direction, and here m2g would be acting in the downward direction. Now we can apply this law. So F1 minus m1g minus m2g is equals to m1 plus m2 times the vertical acceleration ay. We have applied this law in the vertical direction, so we have obtained this equation. Now from here we can easily calculate ay. So this f1 is basically this f only, so we can write f only. Now f we have 50 minus m1 is 2 times g is acceleration due to gravity, its value is 9.81 minus 2 times 9.81 is equals to m1 plus m2 would become 4 times ay. So from here we'll get the value of ay to be nearly 2.69 meter per second squared. So this is the acceleration for the system. Now next we have to calculate the acceleration of the individual spheres. Now the acceleration of the individual sphere ay1, that is the acceleration of the sphere 1, it is equals to acceleration of the sphere 2, and that will be equals to 2.69 meter per second squared. The acceleration would be same because of the symmetricity of the system. So due to symmetricity, the acceleration would be same. Now next I will be considering the B case where alpha is not equals to beta. So in this part we have to consider that alpha is not equals to beta, and then we have to calculate the acceleration for the system in the vertical direction and for the individual sphere also. So first we will be calculating the acceleration of the center of mass by considering as a system, as the whole as a system, and we can apply Newton's second law of motion here, which is sigma F net. We are applying in the vertical direction is equals to mass times the acceleration. So F net we have F minus m1 plus m2 times g is equals to m2 plus m1 times ay. Now we have all the values, we can plug it here. Mass, the force we have 15 Newton, m1 and m2 is 4 times g is 9.81 is equals to 4 times ay. So from here ay comes out to be as 2.69 meter per second squared. So this is the acceleration for the system when alpha is not equals to beta. Now next we'll be considering the we'll be finding the acceleration for individual spheres. So in the B case, alpha is not equals to beta. Now let the tension force in this cable be T1, and in this cable let it be T2. Now we'll be calculating the expression for T1 and T2 in terms of the force F, the given data, that is the force F, and the angle alpha and beta. So for that we'll be making the free body diagram of the system. So this is the tension force T1 and this is the tension force T2. Now this angle is alpha, so this angle would be 180 minus alpha, because this total angle is 180 degrees. Similarly, this angle would be 180 minus beta. So now next we can apply the Lami's theorem, which is F over the sine of this angle, sine alpha plus beta, is equals to, now next this tension T1 divided by sine of this angle, so sine 180 minus beta. Similarly, T2 over sine of this angle, opposite of this, so sine of 180 minus alpha. Now if you see these two terms, we can calculate T1 in terms of F and alpha beta, that is the given data. So T1 from here will be equals to F, we have 50 Newton, so 50 divided by, this is sine alpha plus beta, and in the numerator it would be sine 180 minus beta. Similarly, if we consider these two terms, this one and this one, so from here we'll get T2 to be equals to 50 sine 180 minus alpha divided by sine alpha plus beta. Now next we can consider the free body diagram of this mass m1. So this is the free body diagram of the mass m1. Now we have to calculate the vertical acceleration. So for that we can apply it in Newton's second law of motion here in the vertical direction. So we have if we take the component of T1 in the y direction, so T1 cosine alpha minus m1g is equals to m1 times ay1, where ay1 is the acceleration of m1 mass in the vertical direction that we have to calculate. Now we can put the values. So T1 we have this much, so 50 sine 180 minus beta divided by, this is sine alpha plus beta, and cos alpha as it is, minus m1, so m1 we have 2 times g we have 9.81 is equals to m1 is 2 and ay1 as it is. So here we have only one variable, that is ay1. We can simplify for this, and finally we'll get our result to be ay1 is equals to 25 tangent beta divided by tangent alpha plus beta plus tangent beta minus 9.81 meter per second squared. So this is the answer for the vertical acceleration for the mass m1 in the case when alpha is not equals to beta. Similarly, we'll be considering the free body diagram of the mass m2 to calculate ay2. So this is the free body diagram of the mass m2. Here also we can apply Newton's second law of motion. So T2 cosine beta minus m2g is equals to m2 ay2. So ay2 we have to calculate. Now we can put the values. So T2 we have this much, So 50 sine 180 minus alpha divided by, this is sine alpha plus beta, minus m2 we have a 2 kg, so 2 times 9.81 is equals to 2 times ay2. So from here we can calculate the expression for ay2, and it comes out to be as ay2 is equals to 25 tangent alpha divided by tangent alpha plus tangent beta minus 9.81 meter per second squared. So this is the acceleration for the mass m2 when alpha is not equals to beta. So I hope you have understood the problem. Thank you.